Today, we're going to be exploring skewness in Python and how it impacts the mean, median, and mode for different distributions. We're going to take a look at libraries like SciPy as well as NumPy, and we're going to close out the video by building out two different graphs, one being a histogram and one being a box plot. Box plot you may know as a box and whisker plot. We're going to be doing that with the help of Matplotlib as well as Seaborn. But before we do jump into some coding, I want to take a look at what's considered right or left skewed. All right, so let's take a look at skewness, right, left, and also symmetric distributions. So left and right skewed distributions, here's some of the concepts you should know. So a skewed distribution is one where the data is not symmetrical, distributed around the mean. There are two types of skewed distributions. They're called right and left skewed. You will also see these labeled as positively and negatively skewed. So non-skewed, right, is going to be a symmetric distribution, which you'll also hear the term of a normal distribution. Personally, I use normal distribution a lot more, but for this video, I'm going to call it symmetric. Also, before jumping in a little bit more, please have a little bit of understanding how mean, median, and mode work. Mean is the average value, median is the middle value, and mode is the most frequent value in a data set. All right, so here's an example of a right, also known as positively skewed distribution. The way that you know it's a right is there's larger values to the right side of it. That's at least how I think of it, right? And most of the values are going to be towards the left. And as I mentioned, right, in such distributions, the mean is typically greater than the median. And you can see the values over here, mean 1.95, median 1.37, and mode is 0.01. We're actually going to reproduce this right skewed distribution, the same exact graph as well. But a really good example is going to be housing prices. Let's take a look at somewhere like South Florida housing prices. So I'm from Tampa and Orlando, so I don't 100% know that market down there. But why I say this is a good example is in South Florida, there's a lot of wealth, especially in the Miami area. There's houses that are $50 million, $40 million, a lot of multimillionaires and billionaires, penthouses, different things like that. And there's also a lot of quote unquote more affordable houses, right? Something that costs $300,000 or $400,000. Let's say like the average is $300,000 or $400,000, but you do have those values of $10, $20, $30 million properties down in Miami. Something like that is going to be a right skewed distribution, right? You have a lot more in that $200,000 to $400,000 range, but you do have those properties that are $5, $10, $20 million. Now let's take a look at something that's left skewed, also known as like a negatively skewed. Now the left tail is longer, meaning that the mass of the distribution is concentrated to the right. In such distributions, the mean is typically less than the median. So you can see mean is 5.93, median 6.54, and mode is 6.88. A good example is retirement age, right? I am 26 years old right now. I'm not retiring for a very long time, but there's probably some people in their early, or I wouldn't say early, but their late 20s that are going to retire. Whether they got wealth from their parents, whether they lucked out and won a lottery, maybe they're an ex-professional baseball player for a few different years and retired. People do luck out in life, and some people are fully retired. I will not be retiring anytime soon, especially since I'm making these data science YouTube videos. But regardless, right, people retire young, and a lot more people retire later in life, 60s, 70s, since some people have to retire all the way in their 80s. They don't have the luxury of retiring early. And, that's an example of a negatively skewed one. And a symmetric normal distribution. So as where the values on the left and right side essentially mirror each other, right? Like you can put a line down the center and flip it over. That's how I remembered it from high school. So a good example of this, right? This is also seen as like a bell curve, but IQ scores, right? And you're going to have some people that have very low IQs. You're going to have some people that have very high IQs. And that's a classic example of a symmetric distribution. So with that out of the way, we're going to replicate all this in Python, and we're going to be using Google Colab. So let's start coding. All right, so let's start by bringing in our imports. So import NumPy as NP from SciPy import stats import matplotlib.pyplot as PLT import Seaborn as SNS. Run the cell and we should be able to get going. Awesome. So let's set up a random seed. So np.random.seed, put 13 in over here. And then let's start our skewed data. So we'll start creating our right-skewed data. So skewed data equals np.random. We're going to use exponential. Exponential. And inside over here, we're going to say scale equals 2. Then we'll have our size equals 1000. All right. Then we'll have our left skewed data. So literally all we have to do is left and multiply this by -1 times -1. And then what we can do also is add a number. So we'll say like +7. Left skewed. And then our normal. So normal data equals np.random.normal. And we'll put it around 5. So block equals 5. Scale equals 1.5. And then size is 1000. Size equals 1000. All right. And now what we're going to do is we're going to calculate the mean, median, and mode. So we'll say calc mean, median, and mode for each of these. So we'll start with this first one, which is going to be our right-skewed data. So we'll say right-skewed data, right? And the code is essentially going to be the same for each, right? So what I'll do is I'll set each of these like mean right, then I'll set median right, and then I'll set, oh, actually, let's go one by one. And we'll print them out and take a look. So our mean on this side of things, we'll say np.mean. Then literally all we have to do is pass in our right-skewed data. Mean is that easy, right? And if we want to take a look at this, just print out our mean right. And our mean is 1.94. Now, we want to find our median. So median right equals, and pass in this. And instead of mean, median, right? And print this out. So print. And we'll have the visual side of things for mean, median, and mode later, but we'll see the median is to the left of the mean, right? As I explained in the slides. And lastly, let's take a look at the mode. So mode, right? Now, mode's a little bit more complicated to calculate. So we'll say stats.mode. Then we're going to pass in our right-skewed data. And then we'll have to pass in next is keep dims equal true. Keep dims equals true. And 0, 0, like that. And print that out. So print our mode right. And here we go. Essentially 0 is our mode. And what we're going to do now is we're going to do the same exact thing for our mean, median, mode left, and then mean for our normal. So literally feel free to copy this code. I'm literally just, what I'm going to do now is I'm going to say our left, and I'm going to just essentially put all these together in one cell. So median, and then mode. And we'll do the same with our normal. So normal. And copy all of these and just switch them out, right? So we'll just mark all these as left. And don't worry, we'll be plotting in a minute. So let's just go over here to normal. I'm just showing you really quick how we can find these data points. Normal, normal, and let's grab our left-skewed data. That's the beauty of reusing code. And then our normal data. Great, and we wanted to print these out. So print We'll print out our mean for the left one first, right? So our mean is 5. Then let's calculate our median. So print out our median. Print median 5.6. And then print our mode. Print. While we let that go, let's go and print out our mean for our normal. You can see that's negative 9.2. Well, I didn't run this, so let me run that cell. Mean normal is 5, right? We define that. Print, let's grab our median, right? Also 5, and print our mode. Should also be around 5. Well, that's negative. That's a little bit off, but that's okay. We'll plot these out now. And what we'll do is plot these distributions. And the reason why this mode, by the way, isn't working, you'll see it in a second. When we went over here and randomized it with NumPy, there's so many different options, but the distribution is going to be normal. So, all right, let's plot these out. So what I'm going to do is we'll say plt.figure, and inside over here, we'll say fig size, and what we'll have over here is 21 and also 6. And let's plot each of these out. So what we'll do is plot, we're going to do a subplot. So subplot, that way we get all three together, right? And we'll do 1, 3, 1. So 1, 3, 1. And the first thing we'll do is a hist plot. So sns.hist plot for histogram. We'll pass in our right-skewed data. So let's grab our right-skewed data. That. We'll say KDE equals true. So KDE equals true. We can set a color if we want. We'll say color equals sky blue. And then what we'll do next is plot some lines. So plt.xvline like that. And we'll pass in our mean right. Mean right. And we can set a color. So we'll say color equals R. And then line style. So line style equals, and I'll do dash dash, I think it's 2 dashes, yep. We'll say label equals, and inside over here we'll have an f string. We'll say mean, and then we'll pass in our mean. So mean right, and we'll round this to 2 decimal places. So 0.2f should be that for this line. Yes, it is. And we'll plot a few other lines. So 2 and 3. We'll grab our median, and we'll also grab our mode. And we'll have our colors. We'll say RGB, so G, and then also B over here. Line style, we'll put over here 1 dash, 1 dash, and then we'll say median, and then we'll have mode. And just change these up, median and mode. That's why we built out all these a little bit earlier. These all should be good there. And then set our title, plt.title, and we'll say right-skewed distribution, right-skewed distribution. And we'll set our legend. So plt.legend. And what I'm going to do now is I'm going to duplicate this code. So just follow along really quick. We're going to grab this. And first thing we're going to do is we're going to change our last number on these subplots. So this is 2, and this is going to be 3. And then I want to have a left next. So literally just replace all these rights with left like this. And left, whoops. Just capitalize that left. Mean left, median left, mode left, left skewed, left, left, left. That looks good there. And then now what we're going to have is normal. So I think I have it as normal data. And I'm just going to copy normal. And we'll just paste all these over here. I know it's a little tedious, but it's okay. We're doing a lot of plotting. Whoops, I messed these up. Let me just re-paste these here. And what we'll do, just put normal for each of these. So just grab that. All right, so all these should be here now. And assuming I have no errors, which I have an error. Oh, well, that's why. I misspelled line style. So just fix these real quick. Line style like that. Hopefully that's my only error. Let's rerun that. Also made others. Oh, here we go. Sweet. Sweet, 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 sweet. Yeah, so this mode, it really should be right over here. Maybe I should do a different NP random seed and rerun these, but that mode should be around 5. And I could always fix that. I tested with a different random seed, but same with this one right over here. This left-skewed, the mode should be over here. And it does happen because these are randomized. And if they were whole numbers, it would line up correctly. But regardless, right, you have your mean, median, and you can see how those have been impacted. You can see the KDE, it barely shows, so maybe I should change the color a little bit on that. And KDE normal distribution, right, our left skewed like that, and then also our right skewed right over here. Which is awesome. This right skewed worked perfect, but this left and normal, those didn't work as intended. But regardless, let's take a look at a box plot now. Hopefully this kind of just ingrained how this works, right? And how you can essentially build these out, right? So I just use exponential for left and right, and then just found mean, median, mode, and then we plotted all three together. But we'll plot these box plots now. So just go over here to box plots. And let's plot them out. So box plots like that. And this will also be very helpful. So you can see what this looks like. So we'll say plt.subplot, and we'll do 1, 3, 1, 1, 3, and 1, sns.boxplot. I love using Seaborn. We'll say y equals our right skewed data, color equals sky blue. And then what we'll have is plt.title. We'll say right skewed data, right. Or right skewed distribution, doesn't matter. And I'm literally just gonna copy this a few times. So we'll copy this over here, 2, 3, change this to the left. And change the colors also. Make this light green. Make this a 2 and a 3. So 2 and also 3. This is going to be our left. So make sure that's named on left. And then our third one is our normal data. So we'll just say normal data. Change that color. Light corral. Normal distribution. And then what we'll do is just plot this out. Whoops, I meant to put a few lines. And we'll say plt.tight layout. And then plt.show. plt.show. And hopefully this works correctly. Sweet. So you can see how all these work over here. So, all right, and just to increase the spacing a little bit, I added in one other line. So plt.subplots adjust white space and then top. So 0.6 and 0.8. And you can see there's now a little bit of space over here. But With this right-skewed, right, you can see that there's a lot of potential outliers over here between 6 and 16. Our left-skewed goes from -10 to about, let's say, around 1-ish, right? And then our normal distribution, you can see that there's outliers on both sides of things. So if you're taking a look at a histogram, right, you can take a look and see if a lot of values are to the right. You have right-skewed, right, and outliers over here. But if you are looking at box and whisker or box plot, same thing, right? Values up north, values down here. And that's why you have like positively and then also negatively skewed, right? As mentioned, and then normal you see on both sides of things. And remember how you can read these. 50% of the values are going to line up here, and then 25% are essentially on these stems on each side. So 50% of the values, 25%, 25%, minus what we classify as outliers. And you can see all these outliers right over there. So this is symmetrical, right? Whereas these are not symmetrical. And yeah, hopefully this video was pretty helpful for you. Fortunately, these modes did not work, but that's okay. At least worked for our first example on this right-skewed distribution. Hope you guys enjoyed this video and learned something new about skewness. If you did, make sure to subscribe to the channels. One of our goals is to hit 100,000 subscribers in 2025, and we're going to do that by uploading 3 to 4 data science focused videos every single week. Now, if you want to learn even more about statistics, I have a few videos and a playlist linked down below, or you can click right up here.